Okay, so finding the zero of a function is a term that if you're not comfortable with it, you wouldn't know what to do with that. So what a zero of a function is basically finding when the y equals 0. When does the function equal 0? So we're just doing these short notes today because of our activity, but so the zero of the function is basically asking when does y equal 0? So we're going to find x. So when they ask for a zero of the function, they're asking for x. So in these three examples, finding that 0 just is slightly different depending on the problem. From an equation, it's very easy. We just put 0 in for our y. And like I said, we've done that before. That was like when we found the x-intercept. So this hopefully is a pretty easy equation to solve. Like I hope you don't look at it and be like, I have no idea how to solve that. We've solved plenty of equations like this. I'm going to move that 12 over. So we're going to divide by 3. And so they would call x equal 4 the zero of the equation. It's just a vocab word they use. We won't use it a ton this year, but it's something that does start to come up more often. So on the graph, where does y equal 0?
Origin.
That's one of the places, but on like an actual line. Because the origin doesn't touch this graph. Where does the y equal 0?
The x-intercept.
The x-intercept. So we're going to look on the x-axis. So from a graph, it's a lot easier. We just look at the x-intercept. I don't even have to do any math. So in this case, the 0 would just be x is 3. How about with function notation? Where's the 0 going to go? Yeah, that f of x is just, remember, that's the same thing as y. Just that strange notation we're not quite used to yet. F of x is y. So we just want to know where y equals 0. So again, we're just going to put 0 in there. So again, we just have to solve this for x. We're going to move the 30 over, divide by 6. This would be considered the 0 of the function. So it's just a weird word for just make y equal 0. It's just people who know math don't need to say y equals 0. They just know the 0 of the function is where the y equals 0. And then these next two questions aren't necessarily asking for the zeros. They're just giving us different values depending on the problem. So it says, what's the value of y when x is negative 5? That's as straightforward as it sounds. Put negative 5 into this equation for x. Now, a negative times a negative is going to be a positive. What is that? Is it 21? What's that? What's 4.2 times 5? 21. Thank you. So we multiply those two together. They're being multiplied there. So y is just going to be 29. And then they ask us for what x value does y equal 70. Now this is asking us to put it in as our y value instead. So instead of putting it in for x, we're going to put it in for y. So I'm going to move the 8 over. divide by a negative 4.2. Doesn't like 2's today. What do we get? Negative what? When you divide 62 by negative 4.2? 14 point what?
14.75.
Like 7, 8, something like that? 76, so we'll go 8. All right, so this is kind of the only new thing I really needed to teach you guys today. Otherwise, it's very similar to what we were doing last class along with Barbie Bungee. So making some predictions about equations based off of the graphs. You will have to do a little bit of graphing, so I hope you guys still do have some graph paper left from last time. If you don't, I do have extra graph paper if you need it. So homework is listed here. You guys. Like I said, it's really a lot of what we did yesterday. So I don't think you should need any more notes at all. So 3 through 13 odds and then those 3. Like I said, you probably need some graph paper, and I'm assuming you probably have half of a sheet of graph paper left still from the last time. Any questions? All right.